Hello, everyone, and welcome to the IEEE Young Professional webinar series. Today our webinar is on Moore's Law for Mobile Power, presented by Thomas Cullen, which is the president of Cullen Associates. Welcome to the Young Professional webinar series. I'm your host today, and my name is Matthew Carius. I'm a webinar specialist with the MGA Young Professionals group. I'm also the vice chair of the Toronto Young Professionals affinity group, so if there's anyone viewing in Toronto, I hope you can come out to our events that we're having in the next couple months. And just for your information, IEEE Young Professionals will be hosting monthly webinar series in 2014 and hopefully continuing on to 2015, and on such range of topics including effective communication, leadership, and starting today actually having some technical talks on today's talk on mobile power. So keep looking on our websites for all the upcoming webinars as well. Audience participation. During the webinar, please type any questions you have into the question box below, shown there on our live page through IEEE TV. You can actually vote for your questions that appear below, so that the most popular questions will probably get asked first by myself. All questions will be answered at the end of the webinar, most likely at the end of the webinar during a 5 to 15 minute Q&A session mediated by myself. So we have a new name, new field. We transitioned from IEEE Gold, graduates of the last decades, to IEEE Young Professionals affinity group. IEEE Gold was not instantly recognizable through as a Young Professionals group, which is exactly what we are. The new name makes it easier to find information and benefits when relevant to IEEE professionals, which I'll be talking about on the next slide. We have had great success with this rebranding. We have really successful networking mixtures here in Toronto with anywhere from 150 to 200 attendees, and following that, there's been similar events in the U.S. in Central Texas Mixer, and again in Santa Clara Valley there. Please join us on our Gold Rush blog, where you can actually submit interesting articles for all young professionals to view. Before we get started with the webinar today, please connect with us online. We have two new career-based services, the Mentor Center and the Resume Lab, which I'm going to be talking about in more detail at the end of the webinar. And connect with us online. We have a website there, our email, Facebook, Twitter, YouTube, which is where this webinar will be posted at the end, automatically posted on our YouTube channel, and of course we're on LinkedIn. So please connect and follow us online. So today's webinar, Moore's Law for Mobile Power. Speakers today is Thomas. He's president of Cullen Associates. He's also extensively involved in many IEEE committees and boards, which I'm sure he's going to be talking about in his webinar today. He has an extensive list of patents and publications to his credit. He's also the author of Digital Storage in Consumer Electronics, a published novel there, a published entity there. So without further ado, Thomas, please go ahead with your webinar, and thank you for joining us today.
Hi, thank you for the introduction. This is Tom Coughlin, and so I'm Director-elect for IEEE Region 6, which is Western United States, but I've also been very active in the IEEE Consumer Electronics Society and the IEEE Future Directions Committee in the last few years. I'm a member of the Future Directions Committee, and we formed in the Consumer Electronics Society a Future Directions Committee, so I'm the VP of that. And that's the basis. I'm going to talk a little bit about the Consumer Electronics Society Future Directions Committee, some of the things we're trying to do. And then I'm going to get into the topic of power in our mobile devices. And we'll finally, we'll talk, here's an outline of some of the things we'll talk about: power in our hands, sources of power, safety and sustainability considerations, manufacturability of consumer electronic devices, such as mobile devices that use power, and then finally get into what this is all about, which is a safe advanced mobile power initiative that we're pushing. So let's first talk about things we're doing in the IEEE Consumer Electronics Society Future Directions Committee. Well, first of all, there's a Future Directions Committee in the big IEEE. that is looking at trends and developments that are important for the future of technology and of the IEEE. Those have included things like smart grid, life sciences, cloud computing, and transportation electrification. And so I've been a part of that committee and involved in several of those future directions. In our Consumer Electronics Society, we've been pursuing some things that will impact the future of consumer electronics. So let's take a look at, in the Consumer Electronics Society, the objectives for this Future Directions Committee. First of all, we're trying to serve our particular community of the Consumer Electronics Society, so we want to help bring interesting and important topics to Consumer Electronics Society conferences. We want to help to generate articles for our Consumer Electronics magazine, create new initiatives on important topics in consumer electronics, create a bigger and lasting presence of our particular society in the IEEE, and of course everyone uses consumer electronics, so it's kind of an important thing. Help to create the future. I don't know about many of the rest of you, but part of what got me interested in science, technology, and engineering in particular was to try to make the sort of things I used to read about in science fiction books or watch on science fiction shows and movies. So if you're interested in more information, and this is particularly on the safe advanced mobile power, here is a link down here. But it also there also is information there on the Future Directions Committee. So some things we've been doing at the Consumer Electronics Society conferences. We've got an Internet of Things working group organizing articles and conference sessions. Consumer Home Health has had sessions at conferences like a recent one in Berlin. Sustainable Electronics Committee organized a tutorial session at and participated in Sustainable Technology Conference put on by IEEE Region 6 in July 2014. We've begun to work on last year at the ICCE conference, International Conference on Consumer Electronics, which is right at the end of the Consumer Electronics show. We had a IEEE Future Directions Convergence event that involved people from a lot of different societies working on a lot of these important Future Directions initiatives who spoke there. We're trying to organize another one of those in 2015 at the ICCE again at the end of the Consumer Electronics Show in Las Vegas next January. Again with the broader Future Directions Committee, IEEE Future Directions Committee. And just some information on some of the things, in this case on the Internet of Things. We want to encourage development of consumer-centric Internet of Things as more and more of our stuff basically is connected and interacting through the network, directly related to the creation of an ecosystem considering the consumers at the core. We're organizing special sessions on consumer-centric Internet of Things at various conferences, including this GCCE conference, which is a global conference on consumer electronics, next month in Tokyo. We've got 6 papers in that particular sessions. We also are targeting for, we had a call for articles on the Consumer Internet of Things for the CE magazine, and basically we're at the deadline on that. And although if someone did have something they wanted to do, we could probably still get it in by the end of the week. And we're organizing panel. We're trying to organize a panel discussion on the Internet of Things at the ICCE 2015 in Las Vegas. The magazine, Consumer Electronics Magazine, again, we have this call for articles on a consumer Internet of Things to be published in January 2015. There'll be an article on what I'm going to talk about later here, which is safe advanced mobile power activities in that issue as well, which is based on a white paper that this group has created. And we'll continue to promote and identify potential authors on topics related to the future of consumer electronics in our travels and meetings with people. And over 150 people. Another thing we did the last year was we instigated a survey of young consumers regarding their trends and interests, and perhaps even some of the folks who are on the line here would like to participate in it. The link is still live, and here it is here, and I guess this is going to be posted so you can take a look at this later if you're interested in joining us on this young consumer survey. And here's some results from that. So we got all the way from teenagers to folks in college, and as you can see on the left-hand side here, and we were asking questions like, you know, how many of you have what type of consumer devices, and how much do you use them during the day. So here's a pie chart showing the breakout of that. Since I'm a storage guy, is the work I do, I ask questions related to storage of content, in this case backing up, and so a lot of people backed up to external device at home, some to the cloud, about 20% didn't back up. So anyway, this is some results from the survey, and again, some of the things we've been doing in this IEEE Consumer Electronics Future Directions Committee. Now, let's get to the particular topic I want to discuss here, which is the enablement of mobile devices to be able to do more things, to be able to do it longer. So let's talk about power in our hands. This is a newspaper picture of Nikola Tesla from back around probably around the end of the 19th century, beginning of the 20th century. So with more energy in mobile devices, we can use our devices without recharging for a longer period of time. Now that's important if you have reliable power, because it gives you more flexibility in things you can do, but it can also be life-saving if you're in an area where you have much less reliable power, for instance in developing countries and such. And we can do more with our mobile devices during the course of the day if we had more power available on them. And in fact, it really is true that our personal power, the things that we can accomplish, is tied to the energy, the power, in the very things we carry with us. We will always try to do more with technology that we carry with us because it's convenient, it enables us. So there's never enough power, essentially, that would enable us to do what we're doing now more of, or to do new things. And because there are always, no matter what we do, is some limits on the amount of power available, power management and control on mobile devices is important, both because we never have enough power, but also because the dissipation of that power in processors and other devices can actually cause them to heat up, and if we're not careful, they can toast themselves. So our vehicle that we're looking at for this initiative is basically a mobile smartphone, and we're looking at that in particular because it's a fairly it's a relatively well understood platform device. It's been around since the 1980s. The characteristics are pretty well understood. It'd be a good test bed for mobile technology development, and it's a power technology built for a phone could translate in other mobile devices, and even devices like cars. And you can see along the side here pictures of mobile devices now, and also things foreseen perhaps in the future. If we take a look at the actual energy available in current smartphones, here's a picture. Here's a slide that shows some examples here of smartphone technologies, and we have here vendor statements of the standby power, how many hours of standby power these various devices would have, and their statements of expected runtime. This column here, we show some results of actual runtimes that customers may run into. And then in this far column here to the right, we show the actual installed battery, some characteristics of that, i.e. what kind of battery it is, and how much actual energy is available in terms of milliamp hours, or power is available in terms of milliamp hours. So some popular consumer phones here. This one down here in particular has a much larger battery, which is why all of the standby and runtime hours are longer. One thing that's interesting here, of course, is this actual runtime is considerably less than the vendor's reported runtime, and that's because people tend to do a lot more than what the vendors think they might be doing. And let's take a look at a couple of different use cases. The first one, we'll call it a casual cell phone user. And this casual user might get 5 hours of use with a 1400 milliamp hour, i.e. 1.4 amp hour battery. Now, if that was same use for 7 days, the total energy requirement is 7 times that, or 9.8 amp hours. And if it's a 3.7 volt device, which is not too uncommon, although people are working on lower voltage electronics, then the actual energy use in the week could be 9.8 amp hours times 3.7, or 36.3 watt hours, or 130,536 joules. If you take a look at another Example, someone who is more aggressive or does a lot more with their phone, we'll call that a power cell phone user. In this case, we're assuming 12 hours of intense use with lots of radios running, Bluetooth, Wi-Fi, GPS, near field, downloading lots of data, maybe watching movies. And this person may consume 1,400 milliamp hours in only 3 hours. And actually you want to consume 4 times as much energy to get that 12 hours of use in the day. So that would be 5.6 amp hours. Again, if that's a 3.7 volt device, the energy required then comes out to about 20.7 watt hours. And if that was done over 7 days, this user would then need 7 times that, which would be 145 watt hours, or 522,144 joules. Now, these numbers are important, in terms of looking at alternatives for powering. Now, if we had more power on these devices, we could run more radios more often, allowing us to have better knowledge of our position, allowing us to use peripheral devices such as Bluetooth, allow us to have Wi-Fi connections, to do more stuff with that. There are small projectors, micro projectors that can be built into phones that can give you high definition video directly from your phone, except it uses a fair amount of power. And if we had the power, we could run cameras all the time with multiple pictures per image. And that's important because people are probably going to be capturing their lives, essentially creating life logs. Look at, for instance, my kids. They send pictures to each other, they text, they watch YouTube videos. If they had the technology for capturing stuff that happened to them, I could very well see that being some of the social interaction that they have with others, send little clips of what they did during the day. Of course, the key to all this is being able to create the metadata for analyzing, organizing, and indexing this information so that it can be made useful. But there are technologies out there that are starting to be able to do that, and in fact there are examples of technologies out there that allow people to record stuff, whether it be with a spy pen that you stick in your pocket and has a little camera and a microphone and records things that go on around you, or something you wear in a lanyard, or the long history of wearable computer technologies that people have had. And they're actually a book by a guy named Gordon Bell with Jim Gemmell from Microsoft Research. They wrote on this topic called Total Recall, where they were trying to record essentially a personal petabyte of data that you would generate or use during your life, according to Gordon Bell's projections at one time. Now, it's kind of a big deal from a storage point of view, because if people start recording their lives, user-generated content certainly becomes the vast majority of all content. There's an awful lot of people out there. If they all started to record themselves, that would generate a lot of raw data. Not necessarily that you'd keep all that raw data, but it would generate a lot of raw data. And this is a projection if we assumed a life log running during waking hours, certain resolution, that over a period of 5 years' time you could be generating a considerable amount. In this case, it was like 100 terabytes of raw content in 5 years under these assumptions. So if everyone did that, that would certainly, your life log would be the largest thing in your household. This is just one person. If everyone did that, it'd be quite enormous. So there's a lot of potential, of course, here. If we can do things, it could be used for, again, with the right kind of indexing and organization of information, that I could find something I displaced if I happen to have my camera looking at it, then I can go back and find it, figure out where I lost it. So it could be sort of a memory prosthetic device to remind you of people that you've met in the past, or just be used for social interaction with other people, or capturing significant events, or proving liability in the case of an accident or something like that. Other things we could do if we had the energy: we could provide wireless energy for batteryless wireless devices. Here's an example to the right here, where we essentially have a electromagnetic energy source that then activates a circuit that we can then monitor, and that energy is used to process the circuit and then broadcast out some status or data or transmission, a measurement, something like that. And these things can be important, for instance, in this broader category of things called the Internet of Things. And essentially, by providing electromagnetic energy that could be used to activate such devices, for instance, could be sensors or other things, mobile phones, and also for privacy reasons, we may very well want our mobile phones, or at least local devices, to be the basis of our edge network, of our things that are connected with each other. That then is the gateway and controls access through the Internet and use through the Internet. Other things we could do. We could deal with, if we had the power, the energy in it. A phone could be a source of power for external devices like USB devices. It could be useful, more useful for an untethered Wi-Fi hotspot without burning down the power. And we could have more powerful computers do more complex computations, including, for instance, computational imaging with photos or videos we took on this web, perhaps even part of processing these life logs. And more likely than not, we could do things we haven't even dreamed of yet if we had the power in our mobile devices. So let's look at some of these sources of power. Of course, for Genghis Khan, it was soldiers and catapults and weapons, swords, javelins, what have you. But for us, we're looking at power sources that include energy storage, for instance, batteries, energy generation, for example, fuel cells, energy harvesting of various sorts like motion or heat, or electromagnetic radiation, ambient electromagnetic radiation. And the other possibility might be something like a projected wireless power technology, similar to what maybe Nikola Tesla had talked about over a century ago. Let's look at some of these different technologies. First of all, here's a battery, give you an idea what it looks like. A battery basically has a chemical reaction that generates electricity that then becomes available to a system it's attached to. It will continue to operate until that electrical reaction that chemical reaction is consumed, and then it won't generate any more electricity. If it's a rechargeable battery, then you could use electricity to reverse those chemical processes so that it can run again and generate electricity again. And energy storage devices, especially rechargeable ones, here's one example of a battery technology roadmap from 2012. It's actually looking at energy sources for electric vehicles, but you can very well see that for mobile devices as well, and showing some increase in the available energy, which is here, over a period of time. There's things like lithium sulfur, lithium air, that are looked at as being ways of increasing power available in these devices. Now, the problem with current battery technology is that the energy densities seem to double roughly every 10 years. Now, that's a lot slower than Moore's law for semiconductors, for the transistor densities in semiconductors, or the number of transistors per chip in semiconductors, the speed and availability of networks, and also storage capacity growth of common digital storage devices like hard disk drives or flash memory. And at this rate of growth, the energy density required to run a phone for a week could take decades to develop, especially for that power user we made the case for earlier. So that's a little bit about battery technology. Let's look at energy generation. And an iconic example here would be fuel cells. It's an example of a power generation device that could be built into a phone. It might involve, for instance, on this slide here from Bic, who makes disposable pens, a disposable hydrogen source, which probably is methanol or something like that, which then could be put into a power source, which could be built into the phone, something you insert in the phone, and then that could generate. In this case, it's an external power source, could be used with a plug to recharge your battery, or you could have something that's ideally built into the phone itself, that maybe you put these cartridges in. So that's an example of energy density, of energy generation using a fuel cell, where basically you've got a process that combines oxygen with hydrogen and resulting in the generation of electricity. That's basically what fuel cells do. Examples of energy harvesting: micro, nano machine technologies can be used to create electrical power from ambient energy, which could be motion, heat, electromagnetic, or other sources. Here's kind of a funny example here. This is from a few years ago, but the idea is that you've got a pair of shorts with that the movement of the person wearing these shorts would generate electricity, which would then be concentrated and available in this power pocket and used to charge the phone. So this is just an interesting example, kind of these kind of technologies. And then the final one we talked about was some kind of projected wireless power, where I could have transmission companies such as Witricity and other companies are working to transmit usable power over significant distances. So these are looking at all these different potential ways in which we might be able to power our lives and our mobile devices. But to make this stuff happen, whether it's energy storage, energy generation, energy harvesting, or some kind of projected power for mobile power in order to get useful amounts of energy in our devices in a reasonable period of time. But we also need to meet safety and sustainability requirements. So let's look at some of those. Increasing the energy stored in a phone or any other motor expended into the circuitry at once. It could fry the circuitry, it could get very hot, it could even catch on fire, potentially could damage the user. Thus, the power source must have a foolproof way to prevent massive power draws. The energy source must not also cause other hazards to the user. Its safety is a key concern, otherwise you get people putting lawsuits on you for not being careful. And the mobile device must not emit radiation that exceeds safety or interference specifications, and the mobile device or its parts must not cause any other kind of damage, cutting, rubbing, or other injuries when used under normal conditions in the intended fashion. Interesting slide here, which I actually borrowed from Qualcomm, was looking at energy efficiencies, energy generation for smartphones and tablets, where we're looking at certain emissive characteristics, and then as the surface area of the device gets smaller, you can get a smaller amount of input energy can generate pretty significant temperatures. So there's a requirement, of course, to design carefully to avoid overheating of parts, and also to manage your power usage, both in your electronics, to make the best use of it. No matter what else we do, we're going to have to do that. And finally, on sustainability, this mobile phone power source should last at least 3 years under normal charging use, even for this power user. The mobile phone power source should be easy to replace, so the phone can be repaired or repurposed for a secondary market. Should not contain dangerous substances that pollute the environment. The materials used in the phone should be obtained without endangering human rights. So, a last piece of this segment of the talk before I actually get into the initiative is talking about manufacturing, some thoughts about manufacturing of consumer devices and of mobile power for those devices. So let's take a look at some things along that. Here is a smartphone and tablet bill of materials. In particular, if you look here, we show that all these other parts that go into this, here's the approximate cost to manufacture them. And the battery here was something between $5.50 for the smartphone example to $20 for a tablet. So this leads us to, if we're going to make something like this that's going to be used in consumer devices, it's probably got to have a bill of materials cost of less than $20. And that's got to be, of course, in volume manufacturing. So we've got to design something, an invention that actually can be scaled up into a pilot, and then once you can work out all the yields and process issues, that you can ramp into volume production. So what we're looking at in this initiative is things that can actually be turned into manufacturable products, not just laboratory curiosities. And there's various elements in finished product total cost, which include the components, the assembly costs, and then the overhead of running whatever organization that manufactures it, whether you're doing contract manufacturing or in-house. And then just to give an example of what this could look like, if we're trying to get a net cost, this is on a log scale, of less than $20 to produce, so your bill of materials is $20 or less, say at 100 million unit scale, then fixed cost, which is the cost you have to pay just to have the facility and run it, and variable costs, which go with the volume of units produced over time. That variable cost should become the dominant cost in the part, and your fixed costs get amortized over more parts, and therefore the actual cost per part is much less. That's just what this chart is showing here. So again, moving into this initiative, our goal is to make a power source of one of these sorts for these mobile devices that costs less than $20, 100 plus, 100 million plus production volume, should have a useful life at least 2 or 3 years, should be repairable, making it capable of longer life and thus sustainable. So that leads us into this Safe Advanced Mobile Power Initiative. And the objective of this effort is to create a safe and sustainable mobile energy source for a mobile device. The example is a smartphone, but it could be anything else that can supply a week's worth of normal use without recharging from proximity to a fixed power source. The creation of longer-lasting energy sources for mobile devices will have important technical and social benefits. But to do this, we're going to have to create something like a Moore's Law for mobile power. That is, to create significantly larger amounts of power available in a relatively short period of time so that we can actually use them in our life. So plans for this initiative, which actually we have funding both from the IEEE Consumer Electronics Society and the IEEE Future Directions Committee. In particular, we're doing 2 things with that. We've got 2 workshops that we're putting on this year. One we did in July, and we're working, in fact, have an initial draft of a white paper on this topic that will be available on that website I showed you earlier at the very beginning of the talk. But we're going to complete this white paper, define the problem, discuss safety and sustainability aspects, outline allowable solutions, and discuss business feasibility aspects of the problem. And that version 1 of that is what we did. We created that in the course of working on our first workshop, which was in San Jose, California, in July, which included participation by folks from the X Prize Foundation, BIC, Foxconn, Qualcomm, and other companies. Our next workshop is planned, looks like, for the first week in December in Galway, Ireland. And so if there's anybody there who's in Region 6 who is interested in these topics, this is an invited workshop, so the participants have to be invited, but if you think you have some expertise or knowledge and this is of interest to you, let us know about that. Here's a flyer we did for the event in San Jose. We'll have some similar topics that we would discuss in the Galway workshop in December. So we're working with Peter Cochrane of the University of Ireland in Galway to organize a 1-day workshop, actually a 1.5-day workshop on safe advanced mobile power, again that first week in December, bringing experts from the U.S. to this event, but we're working on participants from Region 8. So again, if you're in that area or you have some funding, you can come and join us, and you think you've got something to talk about that, let me know, and we'll see if we can get you in there. So let's talk about this initiative, defining the problem with package size, power draw characteristics, typical use applications, total energy needed for a week, which we talked about earlier, weight, operating, non-operating conditions, shock and vibration, product useful life, other consumer use considerations. These are all things that we're covering in this white paper. And just to summarize some of the stuff we talked about before, a casual cell phone user may use something like 36.3 watt-hours or 130,536 joules, which is about 26 times the typical energy in a cell phone battery. The power cell phone user, per our calculation, requires something like 145 watt-hours for a week's worth of use, or 522,144 joules, which is about 104 times the typical energy in cell phone batteries today. In order to do that, if we followed the, if we don't have something to accelerate the historical trends on battery technology, we could accomplish this in maybe 50 years. But we'd sure like to have this much sooner than 50 years. Again, the safety and sustainability, we want to cover handling and care, storage of devices, energy safety, fire hazards, standards for safe power generation, expected extremes of temperatures, safety and energy harvesting. In general, define that any device failure is not dangerous. How do you handle the product at the end of its life, environmental impact, choice of materials, and then making the devices repairable to make them more sustainable. So our allowable solutions, again, are longer life, higher energy batteries, which would be power storage devices, other energy storage devices, energy generating technologies such as fuel cells, energy harvesting for local environments such as solar energy or user-generated energy, wireless power that doesn't require keeping the mobile device in close proximity to the power source, like the inductive chargers that people are talking about today. Any other means for providing energy to the mobile device doesn't require attachment or proximity to a fixed energy source. And it must scale in price with manufacturing volume. So if you have 100 million units or more, you've got a manufacturing price of less than 20 bucks for this thing. Must be useful in all anticipated environments and conditions, and once developed, this power system would be useful for many other applications like transportation, power management, power generation, other uses. So, in conclusion, the IEEE Consumer Electronics Society Future Directions Committee is looking for volunteers to help create a vision for the future of consumer electronics. There's one of these needs that we want to address is the need for additional power in our mobile consumer devices to do the things that we need to do. And there are several options to providing this power in a safe and sustainable way. And the IEEE Consumer Electronics Society has created an initiative to promote the development of energy sources for a week's worth of smart phone use without recharging from proximity to a fixed power source. So with that, I'd like to thank you, and we can take some questions. You can see my contact information there. You're welcome to shoot me an email, particularly if you might be interested in participating in that workshop in December. So go ahead. I'm done now.
Thank you so much for a very interesting talk on meeting our mobile power demands. Please, for all you guys participating, enter your questions below, right underneath the video. There we are taking the questions out. I have a couple of questions to start us off. The first being, so Tom, you talked about how our energy demands are going to be increasing over the next couple of years, and how we need to have basically increase the power that's available to our mobile devices. So I feel that that's one side of the solution. Would the other side of the solution not be just making these devices more efficient? And how much do you see efficiency contributing to this to solving this problem than just by increasing the power output?
Well, efficiency is going to happen anyway. You've got to do that. And no matter how much power we actually put in these things, we will figure out additional things we could do with that power. So, you know, if we were carrying these things with us every day, they are part of the things that we do. And just think of it: if you have the capability to do more things, would you not want to do them, right? And that's essentially what these mobile devices enable. So, in a sense, the applications, the things that we might want to do with these devices is almost unlimited, and that means that potentially that power usage is almost unlimited. So energy management, energy conservation, running at lower voltages, all these things are going to be crucial to do anyway. But in addition to that, we also need more juice, and that's the point of this discussion.
Right. So that's a good point that you bring. We have a question from Richard from the United States. Do you have it's a question about, I was going to ask actually, do you have any more information on the lithium air technology you mentioned? Maybe a bit on how it works, or where it's currently being developed, or anything you can add to the lithium air technology?
Well, a lot of these advanced battery technologies, the research is being done, and a lot of its focus is on electric vehicles. So a lot of the stuff I've seen on lithium air and some of those other new lithium technology in particular have been with regard to research for power sources for like electric cars. So that's the place to go look and find that information.
And how far developed is it? Is it very, very new, or do you see that coming out in the next 5 to 10 years?
So there's a lot of talk about doing these things, and some people are more optimistic and some less. Of course, qualifying something for a transportation application actually requires a lot more certification and safety, sort of meeting safety standards and requirements than, say, an ordinary consumer device. I mean, consumer devices must meet some requirements, and you have to show they're safe. But the actual introduction of these technologies for those transportation applications are liable to be a lot slower than they would potentially be for a consumer application. So I would say we're probably some years off to seeing products that would be available using these technologies, in automobiles at least. Possibly in a consumer device, if it's compatible with the needs of the consumer device, it could happen faster. Right. By the way, one of the things we wanted to do in this initiative was we don't know how we're going to do this. We'd love to do something like an X Prize for advanced mobile power source that meets these requirements. That was kind of one of the thoughts we had. in the first place. And that's why we've been talking to like the X Prize people. And they actually were part of our first workshop, and they may also be involved in our second workshop. They're working on some parallel type initiatives that actually may be one of the things that may result from this work is at least being involved in some way with some of those X Prize initiatives.
That's an excellent way to approach this problem, an X Prize initiative. Great. I did have a question regarding, so in the last question you answered, you talked about government regulation and things like that. Could you maybe comment on the government regulation in terms of mobile power? You mentioned safety in terms of the heat of these devices getting higher, or the amount of radiation. Are those the only two concerns, or is there other things?
There's other things too. One of which is, for instance, can I take this on a plane with me? And that was an issue for a while with fuel cells, but fuel cell technology, as long as it's done right, there now are rules that you can take this on a plane. You can take a certain amount of fuel cell fuel on a plane. It'd be like methanol or something like that you can take in a like a disposable dispenser. It's now considered safe and useful in taking it on airlines, and so that takes, at least for that technology, one of the earlier issues with it. So there's a lot of things related to both public safety as well as personal consumer safety. These products need to meet requirements, and for instance, oftentimes it also needs to meet electromagnetic compatibility requirements, things of that sort. So there's FCC rules. There's oftentimes to become useful, these devices must undergo some testing for product safety with outfits like Underwriters Laboratory or places like that. Or there's that's in the U.S. There's other outfits in other parts of the world as well. So it's an important consideration. That's why we made it part of the initiative.
Exactly. It's a good point with the fuel cells and all this new technology being able to enter an aircraft. We're still accepting questions down there. If you have any questions, please enter it below. Which may seem like another question I have. Might be a silly question, but do those wearable pants actually work? Are they?
Well, I don't know if anyone's actually built them, but
okay.
Yeah. But the idea was that you'd use the movement of the nanofibers caused by the person wearing it to be generating electricity. So it's essentially an energy harvesting technology from personal motion. There's other people that I know. There's been stuff like for soldiers and stuff, things like that, is that they use their motions while they're walking or things of that sort to be generating energy that might be used to keep some of their devices charged. So there's people working on their various ways of trying to do energy harvesting, using either heat or motion. In the case of some of these Internet of Things, for instance, by harvesting ambient electromagnetic radiation in order to do some useful work, which requires sophisticated design of these things, nano, micro machine type technologies, that can be used to generate small amounts of energy, or photovoltaic things, things of that sort. And it's an interesting area to see what we can do to use the energy that we create, that we generate during the course of the day, and actually make better use of it. I guess try to reduce our entropy generation.
Right. Well, it works for the watches. They have the motion watches that I think.
Yeah, the watches that'll wind themselves just from our moving. Yeah, exactly.
Yeah.
Or like I still have some of those calculators with a solar cell on it that'll run off of the ambient lighting in a room, for example.
Exactly. Yeah. It's been a while since I used one of those. Everyone again uses their cell phone for a calculator now, pretty much.
Yeah.
I think that's it. That's all we have for questions. I'm gonna move over to my sides here. But Tom, thank you. Thank you so much for a very insightful talk on exactly what we need in terms of our power for our mobile devices.
You're welcome. Thank you very much. And again, if anyone is potentially interested in that workshop in Ireland in December, get back to me. Let me know so we can consider you for that.
Yeah, his email's on the screen there. So thank you guys for all participating in the webinar. Please complete the feedback survey, which I'll be sending out shortly, and also the YouTube link for this webinar I'll be sending out shortly. Our next Young Professionals webinar is next Friday, October 3rd, 10 a.m. Eastern Time, which Corey Atkinson is going to be giving part 4 of his leadership webinar, and this was entitled "Working with Difficult People." Please check out our 2 career-based services that we have. The first being the IEEE Mentor Center, in which we link up mentees with mentors from around the world, actually, where you can actually log in and say, oh, I want to talk to a power systems guy in California or something like that, and we try to actually do a kind of a matching service and help young professionals mentor their way through their first jobs, for example. Excellent segue from that is the IEEE Resume Lab. Please check that out, in which it gives you lots of tips and even interview tips, and I believe an interview tutorial for the resume there, for your resume and for your first job again. If you have any suggestions for other young professionals, products, and services, please email us there, shown at the bottom, and our website is IEEE.org/YP. And with that, I'd like to conclude this webinar, and thank you everyone for participating. Have a good day. Thank you.